Now, we're going to hit volume, and that's going to pretty much cover the rest of what's on the board that we have not covered yet. So there are several different ways we can go with volume. Of course, we're going to start off with the most basic of the types. So I'm going to take this portion right here. This is going to be from 0 to 3 of y equals x squared. But what I'm going to do is I'm going to rotate about the x-axis. What is the volume? Now, let's keep in mind what we did when we were doing area with integrals. What we were doing with area was essentially we were adding up a bunch of infinitely thin rectangles. Well, this time we're not changing anything as far as that's concerned. We're going to rotate this because that's what the directions say we're going to rotate it. Say that again. Yes, it'll be 360 degrees. So I'm just going to take this arbitrary piece right here. Remember, this is microscopically thin. And I'm going to rotate it around the x-axis. And I'm going to rotate this about the x-axis. So I'm taking all of these little partitions and I'm rotating them about the x-axis. Now, what does each one of these individual segments do when I rotate it, each one around the x-axis? What does it form? A circle. It's going to form a circle. If I take this and I rotate it around, it's going to be a circle. So, what I'm going to do from 0 to 3 is I'm going to add up a bunch of pi r squareds. Now, each one of those segments, when I rotate, each one of those segments represents a radius. So what is the length of each radius? And what is the y value? In general, x squared, yes. So my radius in this case is x squared. Now, pi is a constant. I'm going to pull it out. So I'm 0 to 3 of x squared squared. Which is, of course, man, y'all are good. Y'all must have a good teacher. All right, anyway, pi times x to the 5th over 5 from 0 to 3. So this becomes 3 to the 5th, which is what? $243 maybe?
Yeah.
Okay. So it's pi times 243 over 5, so that would be 243 pi over 5. That would be the volume inside of that.
The volume.
Good stuff. Plugging in 3 to the 5th is 243. Does that make sense? Okay. Any other question here? Y'all good? Okay. All right, let me give y'all one to try on your own. Let's go from 0 to 3 again. But let's rotate y equals 1/2 x about the x-axis. So I want y'all to try that one on your own.
How'd you get X off of, or 5 or 12?
I had this 3 in the denominator here because it's x cubed over 3. So pi over 4 times 1/3 is pi over 12, so it's just x cubed at that point. 3 cubed is 27, yeah.
Why'd you take it out?
Say that again.
Why'd you take it out?
I took it out because, I mean, you definitely didn't have to. I like this to be as minimal as possible. So if there's a constant I can factor out of everything, I tend to want to do it. Now, it didn't help in this problem,
Well,
but,
I understand.
yeah, good. Any other question about that? All right, so let's just do y equals x. And we're going to go from 0 to h. Now, h is a constant. Okay, so this would equal to what? 0 to h of
X squared.
x squared dx, right? So it's pi times, well, let's just go ahead and do this. X cubed over 3 right?
Yeah.
And we're going to go from 0 to h. So this is pi over 3 times h cubed. Now, I'm going to change this up just a little bit. I'm going to turn h cubed into h squared times h. Are y'all with me? Now, if this is h from here to here, this is not y equals x, not y equals 1/2 x. What are the coordinates of that point right there? It's h, right? HH? All right. So, h is the same thing as x in this case, right? Which is the radius. So I've got pi over 3 times r squared h. Does that formula look familiar to you? What is it? Volume of a cone, right? Well, what do I have when I rotate that triangle about the x-axis? It's a cone. Yeah, and I intentionally went with a parabola because I didn't want y'all to go to the volume of a cone. This is a cone has to have the straight edge. This is curved. So but anyway, so you could have solved that if you recognize that it's a cone. Of course, you could have just solved it as what's the volume of a cone. Again, the street value of this stuff is huge, and I'm giving it to you for free. This is called the disk method. It's just like disc golf, except it's calculus and not frisbee, and you're not throwing anything. So I guess it's not really like disc golf. Okay, but it is the disk method. All right, so we've got the disk method here. And again, I think y'all can understand why it's called the disk method, because each cross section here would form a disk. Yeah. Now, I'm going to take it a step further, just because we can. Let's take this same region here. And let's rotate this region about the line. Well, let's go with this one. Sorry. Nothing like changing it mid. Let's take the same region of y equals x squared, and let's rotate this about the line y equals -1. Now, this answer will not be 243 pi over 5. Do you think it'll be bigger than it or smaller than it? It's going to be bigger than it, yeah. Because we're going to have, it's still, a cross section is going to look very similar to this, but it's going to be rotated about a larger radius. So what's going to end up happening here is, like, this portion right here is going to end up rotating here. So we're going to have this huge hollow region inside of here. Now, let's talk about how to find it. what is a cross section going to look like here? If I take this and I rotate it and there's this gap right here, what is this cross section going to look like? It's going to look like a washer.
Like a hollow tree.
I keep this washer in here for this one problem. I'll put it away and I'll use it again next year. But it's going to be a washer. There's going to be a solid region being rotated, and then there's going to be a hollow region inside of it. Now, how do we find, remember we're finding the areas of these cross sections, right? So how do I represent the area of this metal portion?
Take away or find the whole thing and subtract that area.
Okay, so this is called the washer method, like I said. We're not going to learn the dryer method. We're only going to use the washer method. Ha ha ha. Anyway, all right. So it's going to be R sub O squared minus R sub I squared. Outer radius, inner radius. No, I mean that's understandable to not catch that. Of course, Owen caught it.
I'm still writing it down.
You gonna make me go yell or something like that? Anyway, all right, that was lame. I'll never use that joke again. All right. So, but that's what we're doing. We're going to do exactly what Murphy said. We're going to get this outer area and subtract from it the inner area. So, let's figure this out. What is going to be, how am I going to represent this outer radius? Well, what was the radius when I went from here to here? It was x squared.
Yeah.
That radius was x squared. So, what is this distance going to be? X squared plus 1. So my outer radius here is x squared plus 1. And that's squared. Now, what is my inner radius? 1. Every time, right? That does not change on this one. Now, we are going to do some problems in which we're going to have something like this where my outer radius is constantly changing and my inner radius is also constantly changing. So, not every time is this outer radius going to be a constant. Okay? Sure, go. Okay. So, let's go ahead and square x squared plus 1. What would that be?
Oh, right.
2x squared. It's 2x squared plus 1 and then minus 1, right? Yes.
Why is it, wait, are we just finding from 0 to pi? That's what we're looking
That's
for.
0 to pi. What was it supposed to be? 0 to what?
3.
3? Golly. Are we okay now? Where in the world pi came from, I have no idea. Well, I do know, but anyway. So, what happens here, this becomes pi times 0 to 3 of x to the 4th plus 2x squared dx, right? Okay, thank you. So, it's pi from, all right, antiderivative of x to the 4th is x to the 5th over 5. And then 2x squared is 2/3 x cubed. We're going from 0 to 3. Okay, so again, 3 to the 5th is 243. Then 3 cubed is 27. 27 over 3 is 9. 2 times 9 is 18. Now here's the good news for you. If you're doing the AP test and this is a problem on the free responsive AP test, you can stop right there. Because once you get to the step where you plug in numbers and you have nothing but numbers, you don't have to simplify any further. But we're in Coach Moret's class right now. I've got to take the fun out of everything. So, how do I write 18 in terms of 5?
90 over 5.
Say that again.
90 over 5. .333 pi over 5. That was my number when I played basketball in high school.
What was that?
All right. Any question about that? So,